In this video, we have two definite integrals to evaluate, and we want to give the exact value. So you look at the first one here. We have 1 over the square root of 4 minus x squared. So we have a difference of squares there in the radicand. You look at the second one. It's 1 over 9 plus x squared. We have the sum of squares there. So we're going to be using formulas we've used before in some of these videos. So for the first one, we look at this formula here. The integral of anything in the form du over the square root of a squared minus u squared has a value for that integral of arcsine of u over a plus a constant. So look at the square root expression here in the denominator for the first one. Have a 4 there. That corresponds to your a squared. Got a minus. Then we're going to u squared. The x then, in this case, we don't have to actually set up a u substitution because you can say the x is u. If I let u equal to x, then du would be, or dx would be du. So this one here we can go directly to the integration here. Limits from 0 to 1, we don't have to mess with those. So the integral for this one then is simply going to be arcsine, and then it'd be u over a. Now in our case, u is x, so just put an x here. And actually put this, we're not going to change anything here. So we can go directly to this right here. The integral of this, according to this formula, would be arcsine of x over a. In my case here, this is 2 squared, so a would be 2. So it's arcsine, or sine inverse of x over 2, and then we just put the limits from 0 to 1. So we evaluate at 1, get arcsine of 1/2. And then it's minus the valuation of the lower limit. So this would be arcsine of 0. So this will equal then what angle has a sine of 1/2. That's what this means. Arcsine or sine inverse of 1/2. And in radians, that's pi over 6. Minus arcsine of 0. What angle has a sine of 0? But it's 0. What's the exact answer? So we just leave it in this form here. Comes out to pi over 6. Now for the next one, again, this is in the form right here. Du over a squared plus u squared. Anything in that form is going to be 1 over a, arctangent of u over a plus a constant of integration. So in this particular example here, the x squared, that corresponds to your u. The 9 or 3 squared, that corresponds to the a squared. A would be 3 here. So we can go directly to the integration. No u substitution needed here. Sometimes you have to set up the integrand in the form needed. But here we can go directly to the answer. So this would be, look at the formula, 1 over a. In our case, it's 9 squared or 3 squared, so a is 3. This would be 1/3. And it's arctangent, or tangent inverse, of u over a. In our case, u is x, a is 3. And the limits of integration then go from square root of 3 to 3. So it would be equal to then 1/3. Evaluate at the upper limit, that'll be 3 here. So it'd be arctangent of, put a 3 there, 3 over 3 would be 1, minus, this is multiplied by 1/3 here, be minus arctangent, put in the square root of 3, so it'd be the square root of 3 over 3. So it'd be 1/3 then, and the arctangent of 1, what angle has a tangent of 1? It's 45 degrees, or pi over 4 here, minus arctangent of the square root of 3 over 3. And you can set yourself a reference triangle if you don't know the values of these by memory. But for this one, this comes out to pi over 6. Get your common denominator here of 12. Combine this. This comes out to pi over 12. Finding your LCD first, combining. Get pi over 12 and then multiplied by 1/3. Get pi over 36. And that's your exact answer. Thanks for watching, and we'll see you next time.